Alright guys, so today we're going to be graphing parabolas that are in intercept form. And we're going to start with one like number 4 because this is a typical problem. Okay, so basically right here we have the factored answers. So if we multiplied x minus 1 times x plus 3 and we unfactored them, that would give us x squared plus 3x minus 3, which would be x squared plus 2x minus 3. And this is our standard form. So we've taken our standard form and then we factored it, and like big X factored it, and we got these guys. So now at this point, these are where our parabola is going to cross or intercept our x-axis. So what we do is we set our our y equal to 0, and we have x minus 1 and x plus 3. And then we're going to split our two factored answers into, like both give them the answer of 0. So x minus 1 equals 0 and x plus 3 equals 0, and then solve. So add 1, minus 3, and x equals 1 and x equals negative 3. So when y is 0, x is 1, and when y is 0, x is also negative 3. Okay, so we could put dots there. We have a dot at 1, 0, and negative 3, 0. So because our a value is positive, this parabola is going up. So it's going to go up somewhere like this through these two ordered pairs. Now the axis of symmetry is going to cut our intercepts in half. So we're going to find the halfway point between this dot and this dot. So 1, 2, 1. So it looks like it's right here. So the halfway point is at x equals negative 1, which is our axis of symmetry. Oops. I was like, oh, I'm drawing the y first, but then I drew the y again. Okay, so I know that my axis of symmetry is x equals negative 1. So I am going to take this x value and plug it into my equation and figure out what my y value is when my x is negative 1, and that'll give me my vertex. So we have y equals negative 1 minus 1, negative 1 plus 3. So that's negative 2, and we have 2, which is negative 4. So our vertex will be at negative 1, negative 4, here, and then it'll go through these guys like that. So there we go. Okay, the rest of them are just kind of variations of that. So like number 3, this guy doesn't look like it, but really these are my two factored answers. So we start by setting our problem equal to 0, so making our y equal to 0, and we have negative x and x minus 1. So we split, negative x equals 0 and x minus 1 equals 0, and we solve for x. X is 0 and x is positive 1. So when my y value is 0, my x value is 0, and when my y value is 0, my x value is 1. So 0, 0, and then 1. My axis of symmetry cuts this guy in half, which is going to be an x value of 0.5, which is fine. So then we plug 0.5 in. So we have y equals negative half times a half minus 1, and we figure out what that is. Okay, so negative 0.5 times 0.5 minus 1, yeah, and 2.5, 0.25. Whoa, oh no, sorry. So when my vertex, my x value is 0.5, then my y value is 0.25, so a quarter. So then our vertex is going to be like here. Since this is my a value and it's negative 1, my parabola is going to go down, so it goes like that. Okay, let's look at number 6. So this guy, again, we're going to set my y equal to 0, and then we have 2x minus 2 squared. So we solve for my x. So the first thing we have to do is divide each side by 2 to get rid of that coefficient that's out there. So now I have 0 equals x minus 2 squared. So then in order to get rid of my square, I square root each side. So now I have 0 equals x minus 2. Add 2 to each side. So then I have 2 equals x. So I have an ordered pair of 2, 0. Since 0 can't be positive or negative, I mean, really, that's the answer for both of them. So it's going to sit right on the x-axis. It's not going to go through my x-axis. And then another reason to tell is because I don't have 2. So if I just have the one, the vertex is going to be touching the x-axis. If I have the 2, then it's going to go through the x-axis. So I have a dot at 2, 0, and it looks like my parabola is going up. So since my dot sits on my x-axis, I'm just going to pick the next number, so 3, and plug it in to figure out what my ordered pair is going to be on the left and the right of my vertex. So this is my vertex and my intercept. My axis of symmetry will be at 2. So then I have y equals 2 times 3 minus 2 squared. So 3 minus 2 is 1, squared is 1, times 2 is 2. So I have an ordered pair of 3, 2. So 3, 1, 2. Since this is the axis of symmetry, it's the same on the opposite side. And then we graph. And it goes up because this guy's positive. I think that's all the different types. Okay, let me know if you have any questions or you need any help. Have a great day. Bye.